Hello and welcome to Interaction Design Module 2 Tutorial 3. So what are we going to be doing in Tutorial 3? Well, we're going to be continuing with our P5 sound form storming, and like was previously mentioned, each tutorial is experimenting with a different way that P5 explores sound. This tutorial is going to be exploring how to use microphone input in the browser. So the first thing we're going to do is we're going to jump in and we're going to take a look at the code. If you can make your way to, and it should be Module 2 Tutorial 3, you should have P5 mic in, and if I just open that up, FFT mic, and there might be a zip folder for it. If I open up FFT, you can see we've got 3 sketches. We've got a CSS style sheet. We've got our index HTML. Those are really the pieces that are going to matter the most. So I'm going to grab that FFT and I'm going to drag it in. If you recall, we talked about FFT a little bit in the first tutorial, and specifically, actually, you know what, I'm going to be able to reduce that. Let's drag this out a little bit so we can just kind of take a look. We're going to look at our index. FFT is frequency analysis, right? So in particular, this piece of code is really fun in that it's going to be looking at frequency analysis. So all of this is the same. You can see we're starting off with sketch.js. So sketch.js, on the inside, you can see that I actually have a couple of links here. And these are really good links that I wanted to include so that you guys can go and look at where people are going with this. There's some really fun audio visualizations you can do that are based on allowing microphone input. So you can see right off the bat we have 4 variables that are being declared. We have an on, we have a start button, we have a mic, and we have the FFT. So the start button is going to end up being a button, a create button. It could be called anything, calling it start button because it's easier to remember exactly what it is, right? We name our variables to be obvious. Everything is using CS6 function syntax. We have create canvas. We're running a no fill here, and I'm trying to think of if it matters why, because I'm pretty sure we're running lines on the first one, but I might be reminded why we're running a no fill on that in a second. We start off, we're taking our on and we're turning it into a boolean, so on equals false right off the bat. Our start button is we have create button, and you can see that we have this long string of text that'll be on the button, right? Click to allow microphone access and start the sound visualization. So this button is going to be for a user gesture in the window. And I wanted to include this because sometimes we don't always realize how much styling we can do in P5 versus in the CSS, and so I thought it would be fun to show you an alternative. So we've looking at sliders and how you can adjust the sliders with creating a different class for the sliders, or a new slider class, and including it in your CSS. This is how you can actually adjust the styling of your different buttons or sliders right in your window as well. So you can see that we're running things. I'm seeing if there's nothing else linking to it other than, and actually that dot size should be there. So there's nothing really, nope, nothing really, just because it's right past, oh, that's why. So you can see that at the end of this create button, there is no semicolon, right? The semicolon is right here, and that's the trick to this. All of these are actually, and you can see, let me see, are any of them, no, they're not even separated by commas. They're all just going to be, basically what this turns into is start button dot size dot style, and all these different styling features. Mouse over. So on the mouse over, what it's doing is it's going to change the way the button looks. Mouse out. So as you leave again, it's going to style it back. And the position is being set specifically. And it's interesting that this way it'll set, and the last time I was working with the button in the last tutorial, it gave me a hard time doing that, but this actually, window width, and that actually now I see very clearly I was using width and height, and then display width and display height, but in fact with position it needs to be window width divided by 2, window height divided by 2. So that's great because you can use this as an example of how you can go in and see how you can style and adjust your button. And then you can see here we have our mouse pressed, which is included in so it's a start button.mouse pressed, and it's using a turn on function. And you can see immediately we get to look at the turn on function, not hiding it anywhere. It's right here, which has, it changes the Boolean variable from on to true. The microphone, you can see that the mic equals a new p5.audio in. This is what sets the microphone up, creates a new audio in object, I should say, the mic.start. Now, this has to happen in the gesture. There's another step, though, that you're going to need to think about, which has to do with how you link your sketch in your on your server when you connect it. You're going to need to make sure. With our Sheridan servers, you're not going to need to worry about it, but it needs to be HTTPS, not HTTP, and we're going to talk about that a bit afterwards. But as long as that's the case, and you have this button set up in the window, it should work. Now, I have had some issues with updates with Chrome with it, and so there's always debugging that has to go into it, but this has worked in the past. So we're going to start off using this. So we have our microphone.start, and then you can see that it's this FFT, which equals a new P5.FFT, and this is a frequency analyzer, right? It's sampling, and that means that it can slow things down a lot too, because think about it, it means that the computer that is the CPU that is part of, it doesn't matter if it's a phone or a computer or whatever, is going to have to be listening through the microphone and then responding to the microphone, like turning it from converting like a sensor. When we talked about sensors in the previous module, the microphone is acting as a sensor for the computer. It's going to analyze it and it's going to convert it from an analog to a digital signal using so this 1024 is a fairly high sample rate, and you may have to reduce that depending on optimizing it for different mobile applications. However, it may work just fine. We're going to leave it at 0.5. It's not jumping out at me why that accuracy is there. I'm pretty sure that speeds it up a little bit, but it could be because it's between 0.1 and 1, so it's right in the middle, right? So you could play with those numbers a little bit and see what kind of results you get differently. Our FFT, where you have to set your input to mic, right? And so don't adjust that. Keep that one the way it is. And then the start button.style, we start off where we don't just start off. When you turn it on, it's turning the style to display none, right? So it's going to, once you do get the permission from the user in the gesture, or the gesture permission in the browser window, you don't want if you're going to be visualizing the audio, you don't want the button to be there anymore. So that's what this is basically showing you how to do. In our draw function, you can see that we have our statement like we had in one of the earlier, I think last tutorial might have had it, where we have our if on. So that means if on equals true. And you might say, well, where's on? And let's just kind of for a second glance down. Where was on? Oh, on, sorry. We had let on equals false. Right, of course, there it is. Turn on equals true. So if on equals true, background goes to 200, which is going to change to a fairly lightish color. Or it's not even going to change it. We're setting it as that. We haven't set the draw here, though, so it might go from a 255 to a 200. We'll see. And you can see that we have these two interesting ones. These are how you analyze the wave. So when we were even talking about the sine waves and the different waves within the oscillator, so that's when you're creating sound. Keep in mind, the microphone has no idea what it's listening to. It's just listening, and it's you have to create the waveform, and then it analyzes the waveform as part of it. These are actually really important in order for this to work properly. So again, just leave those ones. You can console log them to show them, right? But this will work just fine out of the box. Our stroke is set to red, and you can see that we're going into a begin shape, which ends in an end shape. So our begin shape, so this is going to have, this is all tied together, right, in the begin and end shape. So you can see that we have a stroke weight of 2. That's a great place to adjust. It's not very thick, it's pretty thin. And if I recall which one this is, because there's a few different sketches here right off the bat, it's going to be a really, really boilerplate way of looking at audio visualization, because I don't want to influence too much of where you're going to go with it. Your research should. You should start exploring what's possible after this tutorial. And then you can see we have a for loop, which is going to be looking at this idea of, now, where else do we have spectrum? Spectrum. I don't see spectrum anywhere else. Spectrum. Oh, sorry, we called our analyze spectrum, right? So this is just the name of the variable. So let spectrum equals FFT analyze. Here we have, so whatever the result, whatever the value is that comes out of that FFT analyze is going to be the spectrum.length, right? So think of it like an array. So it's a maximum number, right? So we're starting at 0. We're going to whatever the full length of that analysis of the spectrum is, and it's incrementing. And then we're taking vertex. So we're actually creating a vertex here. So a vertex is just like when we do ellipse or rect or anything like that. So a vertex is a point. So we're taking a point and we're saying to the point, use I as your source, and then you're going to map spectrum as the first point. Your second point is 0. Your third point is 100. Your fourth point is the height, and your fifth point is 0. And this is, again, a pretty specific little piece of code. I didn't write that piece of code. I know I'm not explaining it well enough. When you see the magic of it, you'll see how cool it works. Certainly go in and play with this a little bit, but this may not be the area you want to focus on playing, but I'd give it a try. Blue waveform. So you can see that this is named, and again, so we have 2. So we have a red spectrum and we have a blue waveform in the comment here. And in this one, you can see that we've got a different color. So this is going to be blue. So it's 00255. Again, we have a begin shape and an end shape. We have another for loop. We're still using exactly the same. This time we're using the waveform. So one is using spectrum.length. And one is using waveform.length. So they're actually, one is using the waveform and one is using the analyze. And we could look closer at that on P5, but I really want to jump in and show you how it works. And then you can see that out of the end shape, we're setting them to null. And if you recall what null is from, I think we talked about it last term. If not, let's talk about it right now. So null is going to set the values, not just set them to 0, it's going to eliminate them, right? So it basically it's like garbage collection, because it's very easy to have these numbers just keep, when it's listening to things and turning what it's listening to into numbers, how it just starts to build them up, and they're building numbers bigger and bigger and bigger. And what this does is every loop, it's going to clean out all those numbers. So that keeps it, so you can see in the comments, keeps it snappy if you leave it running. So if you just leave this running in the background, you're not going to have what's called a memory leak, where the numbers just keep adding up and adding up and adding up until it crashes. So this will actually keep it running pretty clean. And then in our mouse clicked function, you can see that we're using exactly the same one we were looking at before. But in this one, it's going to be if get audio context.state does not equal running, then get audio context and resume, right? And that's all that's going to do, is it keeps, once you click this, in the window, this keeps the audio context working. Now, let's see what that looks like. So you can see that immediately we pop up, we have a white background, we have our button here, and you can see that fade over it is working really nicely, right? Or the mouse over and the mouse out. So if I click on it, you can see immediately the button disappears, and now we've got these 2 different, did we actually call them different functions? What did we call these 2? We just have these 2 different, we call them different shapes. So we have the begin shape and end shape. So we have the red spectrum and the blue. So let's take another look at those. You know what? I'm going to, let's see if we can look at both a bit at the same time. I'm going to just close that if it will let me. There we go. And I'm going to just collapse that a tiny bit. Oh, you know what? That works fine. So you can see that it's actually using, visualizing it very differently. The way that it looks as a wave is very different than the way it looks as it's analyzing the, and it's funny because it's analyzing the FFT. Now I really do want to look up the difference between sort of waveform and analyze. So let's pull that up. So we're going to do P5 .js sound. Oh, actually no. Let's do FFT. FT analyze reference. So it's just going to take us to P5, which shows us that's, and you can use FFT on a sound file you do upload as well. So you can, one of the things about these tutorials I want to be really clear on is the reason why we're giving you guys such a range is that you can mix and match stuff. Like you can go in from one and take things and add them to another, and that's my hope, is that you're going to see different ways of doing some of the same things, but you're also going to see different ways of approaching the form storming, so that it really is going to depend on what of these tutorials jumps out at you in order for your form storming to go forward. All right, so we have that vertex, which is great, but let's see. So we have FFT stands for Fast Fourier Transform, is an analysis algorithm that isolates individual audio frequencies within a waveform. What's instantiated? A P5 FFT object can return an array based on two types, and here they are. So FFT waveform computes amplitude. So it's basically listening to the volume, right? So the waveform is responding to, oh, but you know what's funny? I would have thought it was the other way around, but computes amplitude values along the time domain. The array indices correspond to samples across a brief moment in time. Each value represents amplitude of the waveform at that sample of time. So the wave is still responding to the volume. FFT analyze compute amplitude values along the frequency domain. So analyze is looking at frequency, and waveform is actually looking at the, I believe it's volume, but it's interesting that it's looking at over time, right? So they are responding a little differently that way. And I would suggest that if a lot of the P5 sound is really interesting to you, that this is going to take maybe a deeper dive. But for us to play with, I don't want to do the deeper dive. I want you guys to be able to go in, regardless of your interest in using this, and be able to play with it and create a visual response with it. Okay? So that's where we would go to get more information. You can see here, when we're talking about the length, the array is in 1024 bins. So in fact, we're at the sort of the top level, I believe. I don't know if you can go to 2048 with it, or if it's dividing it, because the actual size of the FFT buffer is twice the number of bins. So you should probably leave it at 1024. Anything else in the parameters? We have our set input, the waveform, analyze, get energy. That's interesting. Returns the amount of energy. This is a place to go and start to explore, because we're not doing that. Get centroid, so smooth, lin averages. All of these elements are here. All these other sort of functions. Get octave bands. That could be a great one. Though, and I actually have used that before. It's really cool. These are all places to start exploring with your form storming. So I want to show you how easily you can jump in and start doing that. All right. So this is, let me see. I think that's the end of the first one. Let's open up and take a look at Sketch 1. So we're going to go from Sketch, to Sketch 1. Let's save it. Jump to Sketch 1. And you know what? For a second, let's just kind of take a look here. Same links. We still have our on, start, mic, FFT, amp. None of that's changed. Amp, actually. Did we have amp? No, amp is what's new. Okay, so you can see that we've created a new variable here called amp. Here we have amp equals a new P5 amplitude, right? So that's a slightly different one that we've looked at. And then we have amp set input mic. So we're using the same kind of function for the set input, but we're now using a P5 amplitude compared to when we had opened a where is it? Our just FFT, right? So this is going to be a slightly different way of looking at that. Same button with our turn on. Now here's what's interesting. So we're still doing a audio mic audio in, mic.start with our button turn on. FFT equals still the same way that's working. And where do we fit? Let level equals mic.get level. So we're going to be looking at the potentially the volume of the mic more than anything else. And as I'm looking at this, I don't see anything beyond that part other than it's using the level there. And the place where it's showing is in this ellipse. You can see that the width divided by 2, so with ellipse, remember that you're talking about, 4 values or 4 parameters, and those 4 parameters are going to be, so these first 2 are setting the size, the location, so it's width divided by 2, height divided by 2, so that's basically right in the middle of the canvas, and then level times width times 2. So this is going to be the size of the width and the size of the height, and they're both based on this width value. Okay, and again, it's setting the spectrum. Do we need to? Yes, it's setting the spectrum to keep that clean. Everything else is the same. Let's see how different this one looks just by changing that output. I'm going to click. Okay, so now you can see that there's an ellipse, and the ellipse is responding to volume. And there's lots of places you could go in and start playing with that. Let me collapse that a little bit so we can just kind of, oops. There we go. I'm going to collapse that, and I'm going to close that. So the difference between those two, you can see that we're using very similar. We're using very similar frequency analysis. We're using very similar frequency analysis, but we're using it in a different way, and we're using it visually strikingly different. And I wanted to show you this to show you that there are lots of different ways that you can express sound. And so really what we're doing is we're visualizing sound this way. So I'm a little curious. One thing we didn't do there is I want to see what happens if the background, let's say I set that to 10 like that other one. So now how does it go? Oh, there we go. So that's exactly the kind of place I want you to be able to look at when it comes to your experimentation, right? There's lots of ways you can go in and you can start playing with this, including fluctuating the size of the stroke, or the color of the stroke, playing with all those things. Visualizing sound is the point. So looking at ways that we can make the the mic analysis, the FFT analysis, more interactive, right? And more powerful. Great, that worked out awesome. So let's look at our last one. So let's go to our index and change this to 2. And this, of course, is going to be our last one of our last example of the week of these tutorials, of tutorial 1, 2, and 3. So you can see that not much has changed here. We still have the same variables. We have our on equals false. We still are using the amp with a new amplitude. We're setting our input to the mic. You can see we're adjusting the color. So we're using color mode HSB. So we're changing it from RGB to HSB. If you haven't looked up color mode, that's a great place to begin some of your form storming. Stroke cap. So stroke, when we look at the stroke around any kind of a shape, stroke cap is usually used for edges of things like a line. So if you have a line, and a line is going to often have a squared off end, stroke cap allows you to adjust where if you want it to be a round, and there's a third option, but it's just not jumping out at me. There's 3 different options for stroke cap. Again, great place for you to go and look up, project for rectangles, round for circles. So these are different ways you can go and play with how you want this to visualize. Sound equals 1, so it's setting, do we have a sound here? Let me see. haven't set sound there on amp. That's interesting. Sorry, let me just scroll down for a second. I'm looking for a let sound. I'm assuming I missed it. Oh, that's also, that should be there. So let sound. Okay. Sound equals 1, used by a load to check if the sound has been properly loaded. Radius equals height. So this is setting the size of a circle, right, of an ellipse. So height times 3 divided by 8. Number equals 100. So this is making the number of points on the circle. So this is also a great place to perhaps go and play. Base angle and angle. So that's interesting that... And this let sound may not work if these are tied more specifically, but I don't believe so. Radius, number, base angle. Used to draw the circle of points. I know what this looks like, and I'm just wanting to make sure that I can explain this. Base angle, I'm pretty sure it has to do with that. What we're going to see is going to have lines extending out from an ellipse, and therefore there has to be an angle that they are leaving the ellipse, so to speak. So that might be a place to play with as well. Angle equals base angle, so it's just setting this variable to this variable used to draw a circle of points. Yeah, that's, I think, the best I can explain that. It's translating it, so that's going to put it into the middle of the screen. It probably is setting it to the top corner, which a lot of these will do. So it's translating everything, moving it to the middle of the screen. Rectangle equals 0. This only needs to be a non-zero if using stroke, cap, project. That's a funny one, and I haven't played with this code enough to know exactly what that one does, so I'm going to suggest you go in there and play a little bit with that one. The previous code was a piece of code that was mine. This one is actually one that I was able to sort of pick up and grab for you guys. What else? We have our start button, which is the same as before. We have our turn button, which is the same as before. All that's the same. In our draw, we have our on Boolean. And you can see that there's some really interesting things here. We have our magnitude equals the radius divided by 20. We have our angle, again, with angle equals base angle, which that's funny because we've already said that. So sometimes it does have to go in the draw in order for it to repeat. So I'm going to leave it there for now, but that might be a place to play with. It's funny how the waveform is declared, but its value is never read. So it could be that that's it just lasted from the last one, like it survived the process of going from one to the other, but we never use it. It's interesting that Visual Studio Code tells you that it's not used. It'd be very handy. You should always look for those moments where like it analyzes. Like you see now it's not noticing it the same way. I'm going to take that out, but it let you know that you've kind of like declared and defined something and you're never using it in the code. Now we get to the sort of meat of the shape, right? So we've kind of created given values to all those things, but here's our begin shape. Now that's also interesting that it's translating it again, and I'm wondering about that initial translate now. That's really interesting to me. I would actually like to go in and to play with this and comment a few of these out and see how different they are, whether the draw requires them. Because in the begin shape, if they're there, it means they're going to be included. So is it something that has to happen in the setup and then it repeats itself? Usually not, but it's possible. Because this translate, we shouldn't normally need the two translates that way unless this is just a translate of the begin shape, and it could possibly be that. It's not in the for loop though as well, so we'll see. I'm going to try to comment the other one out and see what we get. You can see that we've now I'm also really curious how unless spec is a specific command that's part of one of the libraries we're using. I find it interesting that I'm not declaring it. And it hasn't called it out. So spec equals spectrum, and it's using this for loop, right? So it's running the for loop from 0 to number. So whatever the number of number is going to be the highest point. And I'm looking through it, and I'm looking for number. There's number again there. Here's stroke I divided by number. Number equals 100. There it is. Okay, good. Always get used to looking for what those are. Look through your code, get used to reading your code so that you can play with those, because they're connected very directly, right? So that number 100 is here. So this is a for loop from 0 to 100. Spec equals spectrum, which is, again, whatever number it is. So if it's at 0, 1, or 2, it's going to be there times 2. So most of the 1024 parts of the spectrum are used. So this is running through it, and so it's really connecting this idea of spectrum being a length of color, I believe, to spectrum being a length of sound that we're listening to. Size equals, and it's SQ. Now that's an interesting one, and I'm not sure what SQ is for. Let's look that up. So P5 SQ square. Okay. Oh, wait a minute. Oh, it's creating a square root. Squares a number, multiplies a number by itself. The result is always a positive number, as multiplying two negative numbers always yields a positive result. Okay, cool. So good. Always, whenever you have a question about that, especially, so anything that's going to show up yellow like that is going to be something that you can go in and figure out more about. So if you're still confused about map, it's a great way to go in, because you can see that we're using spec, which is, you know, I'm still surprised that I haven't declared it, but as the input to map, and we're mapping 0 to 0 and 255 to 1, right? So we're mapping a sort of a wide spectrum to a very short spectrum. And that is also something you can play with quite a bit. We have our level again, which we had before, which amp.getLevel, so it's going to be listening to the current volume. Now, here's something that's going to be a little bit different than what we've looked at before, but you may have seen this in other classes where we're looking at our sine and our cosine, right? And sine and cosine are used for a few things. You can see that here it's using trig. Let me see if I can find something that makes it a little bit, and we probably don't need it specifically to be, and are we doing, yeah, cos. Sine, cosine examples, reference. So we have our sines. You can see that it's wave, right? So it's specifically a wave. You can see that. Now, one thing about a sine and a cosine, it's often used within a time-based media because it actually moves. So it's not just looking at a wave, it's actually plotting within a specific movement. So between the sine and the cosine, you're often going to have a relationship that way. So this is using it to get the inner chords of the point on the circle. All right, you don't have to play with that one. That one kind of just works as part of the mechanics of it. We have a modifier that this is probably a little more confusing. So this basically calculates the length of each line. So this might be also a fun way to go in and play with the visual way it's being represented. And we're then creating an x2 and a y2 variable, and that's interesting that x2 equals x1 times modifier, x2 equals y1 times modifier. So it's taking the sine and the cosine, and it's then adding the modifier to it. So this is a bit of the magic of this piece of code working. Stroke weight is pretty basic. So the stroke weight here is taking the level as part of what's going to adjust the actual thickness of the stroke. And that might be a great way to take into the previous sketch, right? We can go in and actually adjust the stroke weight dynamically instead of just setting it. The stroke is going to be, so here you can see that the stroke is going to be a series of different colors. So it's taking I, so that's, it's not going to be just one color. So the red spectrum, you can see it's like RGB. The red spectrum is actually going through whatever I is of this for loop, right? So taking at any point what that is, and it's multiplying it by 360 divided by number, which is 100. So each of the 100 strokes that's going to be created, that's coming out of an angle out of the ellipse based on the sine and cosine of them, is going to be a different color. Okay, so rainbow of colors. It's setting it all to a line, right? And here you can see it's taking the x1, right? So the sine, y1, the cosine, x2. So this is the beginning point of the line, and this is the end point of the line, right? And it's running it through pi, running the angle. And that's about as good as I can explain that one. I'm hoping that at least it makes it clear enough that you can go in and play with it. The rest of it, you can see we still have our spectrum null, waveform null, which is going to clean out the garbage or garbage collection, and then our mouse clicked is identical. Okay, let's see what that looks like. Oops. Let me just clear that out of the way. Okay, so now you can see that we have this interesting ellipse. You can see that we have 100 lines that are going out of it. You can see they have their caps are rounded, so they have like a nice rounded kind of color or rounded shape to it, right? You can see that it runs the full spectrum all the way around. So those are the way those elements are connecting. And it would be easy to go in and, oh, you can see there how much that CSS is still affecting. All the ellipses are still affected all the same way with the CSS, right? Which is interesting, but also I would say I would want to control that a little tighter. And I'm going to, maybe that's a challenge for you guys to go in and look at doing that. So this will take us to the point of the code where those are just the three that you're being given to go in and start playing with. Again, please go in and start mixing and matching code from different elements to come up with something that's really unique. I'm going to go back to our lecture. So now, I mentioned before, and this is important, and it's easy to get caught up in everything else, and in fact I could even write it this way. So it should be must use HTTPS, not HTTP. The S is for security. Whatever server you're uploading to, your sketch needs to have a security certificate that the browser can confirm. So if you do this on your own and use P5 later for anything, you need to make sure that when you upload it, that it has a security certificate. It's fine for you to test it. You don't need a security certificate to test it in Visual Studio Code, but you're going to need it to upload it to your Phoenix server. So what that means is when you send a link in any kind of a URL, your URL has to have the HTTPS. So if you go and upload it and it doesn't work, first thing you need to check is that. You need to check the address to make sure that the URL is using HTTPS. It's not the default, so expect that to not work until you do adjust it. So make sure any of the links you do in Slate in the Dropbox include HTTPS. All right, and to show you an example of that, I actually have a I use this code, so I'm not actually kidding. Like I use this code in my own website that I have uploaded for a specific bunch of work that I created. And when I click on it, it takes a little while for the analysis to kind of set up, but in the background it's actually working. I've given permission to it, and we should see it start to come in any minute now. Oh, I scrolled away and it started to come up. There it is. It's quite bright, actually. And to me, that takes a little bit too long. I would definitely want to go in and keep playing with that. I had created it a couple years ago, and I haven't gone in and played with it much since. This is to be also one thing I want to mention. You guys are the first group in our program where we've ever had a project that focuses exclusively on sound. So this is an exciting thing. So for me, I've worked with sound analysis and with visualizing sound for years, and this is kind of a chance to introduce it as part of what P5 does, because it's a really powerful tool. So this is a way that I'm using different elements from the things that you have been looking at in a single sketch. And what I'm trying to do is visualize sound here, but you can see how this works. And what I want to point up is right up here in the top window, HTTPS, and then that's the URL. Okay. The rest of it is not movement stuff, and we're not going to focus on that at all. But I just wanted to show you that in particular. And with that, when you're doing your form storming, what we want you to do is, again, same as the last two, play with the mechanical way the code works, play with the aesthetic way the code looks, follow your curiosity. Even if it breaks the code, just download it again. But again, always be saving your different versions. When you hit those aha moments, they are special. And once you lose them, because you go further, sometimes they're gone, right? So save often, change the names of things, and just keep them loaded within the same sketch. And with that, guys, start form storming.